All right, before I start, I want everyone to take a second and just think about the medical field. First thing that came to your mind was probably doctors, right? Whether it be a heart surgeon or your family practitioner or the anesthesiologist in the operating room, most people first consider those professions. But have you ever thought about who makes the MRI machine you go through when you injure your knee? Or who creates the prosthetic limbs that rehabilitate people every single day? Or what about the people who create the tools that surgeons use when they're in the operating room? My point is that there are so many people who work behind the scenes of the medical field to allow doctors to do their job the best that they can every single day. And among these people are biomedical engineers, the people who research and develop new products and technologies to improve healthcare. Without them, operating rooms would be far less innovative. The process of diagnosing patients would take way longer, and overall, the medical field as a whole would just be far less efficient. One day, I hope to be a part of and contribute to this revolutionary field. Hi, I'm Brittney Williams, and I'm a senior in Frisco High School ISM studying biomedical engineering. So like the rest of us, I started with my career outlook assessment, and I had this idea coming into ISM that all I needed to know was that I wanted to be a biomedical engineer, that it was super specific, that there would be a straight path for me, and I'd be ready to go. But I could not have been more wrong. Doing this assessment and reading about everything that comes from being a biomedical engineer and everything you can do with that degree, I was overwhelmed by the options that were in front of me. It was like I had to choose a topic of study all over again. I could go into medical imaging, I could be a clinical engineer, I could do artificial organ creation or prosthetic development. I mean, the opportunities were almost endless, which was both exciting and daunting because I just did not know where to start. So I decided that it was time to dive into further research and just try to find where my passion really lies. So that brings me to my quote, which is, "Success is no accident. It is hard work, perseverance, learning, studying, sacrifice, and most of all, love of what you are doing or learning to do." And I had to put this in my heart and take it really seriously as I went through the year, because I knew it was going to take a lot of hard work to really find what I wanted to do, and a lot of perseverance, a lot of studying, and a lot of learning, and to find that thing that I just love and that sets my heart on fire. So I started with an article about prosthetics and orthotics, which I learned that reading it, I was just amazed with how noble of a job it seemed, because it's all about helping people who have, many of them who have been injured maybe in the Army or doing very noble things like firefighting or working in the military and things like that, and just bringing them back to be their whole selves and just giving people their regular life back, which I was in awe of. I was like, that's just amazing. And it's just helping the people who really need it get back to how they should be. And so it really struck a chord in my heart, and I saw a future for myself here. So I was like, all right, that's awesome. And there was also a lot of room for research it talked about in my article, so I could definitely see a pathway for me to get into it. But then I thought about, do I want to only do research and that kind of thing? So there was a little hesitation there, but it definitely was a place for a starting point. So I decided to do my next article on something very different to see where else biomedical engineering could take me, and I did a research assessment over deep brain stimulation. And as you can kind of see in this picture, deep brain stimulation is about putting sensors in different parts of your brain and sending electrical signals to them to activate parts that don't work or to inactivate parts that are working too hard. And in the article I read, it was being used to treat mental illnesses and neurological disease, whether it be depression or more of a disorder, or like Parkinson's, which is a disease that plagues so many people. And so I was really interested by how biomedical engineering could be used to combat disease rather than just physical ailments. But it was totally different from the orthopedic aspect, which I read about in my last article, and it was a lot heavier in electrical engineering, which for me isn't so interesting to me. I much prefer physics than electromagnetism and that kind of thing. So I kept it in mind, and I later interviewed a lot of people who worked in neuromodulation, but it kind of took a back seat to the orthopedic aspect of biomedical engineering, which I was more interested in. So for my next research assessment, I went to cartilage regeneration. And cartilage regeneration is creating tissues to go in where broken tissues are, or fixing tissues that are broken, and allografts and autografts and all that good stuff. And this was a case of me finding out what my passion is not. I read through this article, and to be frank, I was pretty bored and I was not interested, and it just didn't click with me at all. So, which is unfortunate, because the thought of cartilage regeneration is really cool, and that you're creating new things from different materials that are put into the body, but I just was not interested in the whole process of it, because it's a lot of chemical and that kind of stuff. So then that also helped me narrow my pathway a little bit, because I figured out what doesn't interest me. I knew chemical was not the way to go, and I was again brought back to the physics. So for my most recent research assessment, I did one on external limb devices, which was my favorite research assessment so far. It was very heavy in physics, so it was perfect for me. Orthopedic side of biomedical engineering, which was great. And so what it is, this is a device right here. It's a WREX device, and this is a girl whose arm doesn't move like ours do, because she has some kind of maybe a nerve disease or a bone disease where she can't move her arm and do regular activities like just eating and raising her hand and things like that. So these devices are used, a lot of them in children, to help them move their limbs the way that we think is normal, but it's not normal for them. So it really interested me in helping people with deformities and such live a normal life, because it kind of goes back to the prosthetic side, but I could see more different applications and different ways to take it with deformities, because there's so many possibilities there. And it was very physics heavy, like I said, so I really enjoyed that. And it was cool because I could kind of see the physics topics that I've learned about put to use in real life. So I knew a lot of the concepts it was talking about here, which was really exciting for me. So I really enjoyed this research assessment overall, and I think it led me in a really good direction going into my mentorship and who I'd like to choose as a mentor, and then it led up to what I decided to focus on for my original work. So after my research assessments, I had a whole lot of clarity. I didn't have this huge, daunting, scary cloud in front of me, scary fog, not knowing where I was going. I now knew I wanted to study something on the orthopedic side of biomedical engineering, something to do with bones and like joints, knees, shoulders, hips, that kind of stuff, over things like the cartilage and chemical inside the body stuff. I wanted to do external devices, things like braces, or those devices that help with limb movement, maybe prosthetics, something like that. And I also knew I wanted to be in the creation of things, those development, that creative side, because most of all, when I was reading those articles, what really stood out to me was that they could create these things from nothing, and that they came up with these amazing ideas to help people. And it was so cool hearing about that part. So I knew that was exactly what I wanted to do. So these three things gave me a lot of direction moving forward with interviewing and knowing who to interview, and my interviews also supplemented this clarity of mine, helping me decide which way I wanted to go. So now I go to the interviews, my very favorite part of ISM so far. My first interview was with Dr. Eric Waldorf. He is a principal research scientist at Orthofix, and he works Orthofix. It's an orthopedic company. They do devices and different biologic products for orthopedic needs. And one thing I found very interesting about his job is he works on a variety of projects all at once. He showed me a whiteboard, and it was just scattered with projects. It was so cool to me how he could work on something that had to do with rotator cuffs, but then he was also working on knees, and he was working on electrical stimulation for hip joints and stuff like that. It was just cool, so cool to me that he had such a variety of things to work on. And so his job was very interesting to me. It was awesome to hear about for my first interview, since I had so little knowledge of the field as a whole. And so that was really neat to hear about all the different things that you can apply biomedical engineering to. And so as far as advice he gave me, we talked about broad career paths and how with a biomedical engineering degree, you can either go into industry or you can stay in academia. Academia being research in labs and literary research and things like that. And when he was describing them to me, industry is more like creating products that are going to be on sale and creating hard things. and academia is the research and the helping products get made with that research. And so I kind of knew industry was going to be the path for me. That was something I wanted to do, create tangible objects that I could see in action, and just because it kind of seemed like more of a rewarding thing to me. And we talked about how to get there. Dr. Waldorf is an extremely educated man. He had an undergraduate degree in aerospace, a master's in aerospace, a master's in biomedical engineering, and a PhD in biomedical engineering. So he gave me a lot of great advice on education and how you can take that. And he advised me almost not against a PhD, but he almost warned me that if I wanted to be in industry, a PhD might not be the best degree, because a lot of employers see it as you're an academic, you just want to be in academia. So it's sometimes tough to get into industry after having that PhD behind you, even though it's so much experience. And then we also talked about possible jobs you can have within it. So you can be, he talked about being in research and development, which is what he is in, or being in the more clinical testing side, which is taking an idea that's been had or a product that's been kind of rough drafted and putting it through the whole process of putting it in cadavers and animals and things like that to decide if it's really going to be a good thing. So hearing about that, I still wasn't kind of sure. Both sounded really interesting to me, which was good to me. And we also talked about important qualities, which was a huge part of this interview, because I had an idea that being an engineer was working individually and doing a lot on your own and just technical skills. And he told me the most important personal quality is being a good team player and being able to work with people. And I was so glad about that, because I think that's a strength of mine, and that I can work with others and talk to others. So that gave me a lot of encouragement going into my further interviews, knowing that I could be qualified for a job in engineering. My second interview was with Mr. TJ Baggett. He is a clinical engineer, the more clinical side of testing and getting products out there and such. And he works at St. Jude Medical, which they do neuro-leads development. So he had a much more neurological focus. Very different to Dr. Waldorf with his orthopedic focus. So it was really cool to hear about how interested he was in neuro and how things work with that. And he told me he's on a lot of long projects. So as a clinical engineer, it's more like 2 to 3 year projects, as where Dr. Waldorf's projects were about 3 months. So that was something to think about when I was considering mentor choices. And one big thing I really learned from this interview was professionalism, because we met at a Starbucks